I just make a short intro. Great thanks for, first of all, for our panelists. As I said before, it's a special contribution from universities from Japan that they are working and dealing with issues on environmental challenges in Central Asia, mostly in terms of water, but also in terms of agriculture and desertification, as well as in terms of agrobiodiversity. So I think it's going to be a really nice enlightening from another perspective from universities that they are really in the very high ranking and in very top-notch research on what they do in the region of Central Asia. So I leave now the floor to Dr. Temur Khujanazarov, and the floor is yours, Tim.
Thank you, Stephanos. Good morning, everyone. My name is Temur, and I am a researcher in Kyoto University, Disaster Prevention Research Institute. Hello and welcome to session number 7 in environmental challenges in Central Asia, with contribution from Japanese universities. Also, I am not Japanese, but right now I am in Japan, and I'm happy to welcome you all. And I would like, first of all, to thank all our panelists for coming and making presentation today. In the previous session, we have a lot of discussion on policy issues and social impacts. In this session, as far as I see, we would be talking about more, let's call it quantitative, qualitative, and physical measurements for in terms of modeling, in terms of environmental impact, in terms of how we assess and what do we think of the future of environment and water resources in the region. And in terms of when we do research, when we conduct the research on the big public groups, as was previously discussed in previous session, we have a lot of subjectivity issues. In this case, we have issues in terms of bias of measurement equipment and also subjectivity of a presenter. So if you have any questions for the presenter, I think it would be the best to do the questions after presenter made it, so we can follow up his presentation and ask him all interested questions. So without further ado, I still have 1 more minute to say something, but I would be not using that time. So we will move on to the next presenter, which is surprise going to be me. And yeah, so I will start by sharing my screen. And okay, first this one. Okay. So yeah, as I said, we will have 15 minutes presentation and then 8, 9, as far as we go with the questions. So I hope all audience and colleagues will join us in the discussion, because we all know each other from Japanese university session, so-called. So and we have lots of questions to each other, but we would be happy to answer yours. Okay. So in my today's presentation, I would like to talk about water insecurity. By the way, can you see my screen? Everything is okay?
Yep.
Okay, thank you. So I would like to talk about water insecurity and salinization in the Aral Sea Basin. And my research is also based in Uzbekistan. I think it is quite comparative, or we have almost same conditions in Kazakhstan, Turkmenistan, and some places of Kyrgyzstan and Tajikistan as well. So for let me try. Okay, great. So Central Asia is one of arid zones in which have severe water shortage and in the world, and because of population growth, climate change impact, as well as serious anthropogenic impact for in terms of expanded irrigation. And this was seen over the last several decades of the 20th century when, let's call it experiment on serious expansion in agriculture and development of wide irrigation network in expense of environment. In terms of consequences, the Soviet development strategy, it has positive, of course, and some negative impacts, and long-lasting negative impacts right now is very much visible right now, and change the whole region and land cover and so on. If we check that all countries in Central Asia, as in terms of water consumption, especially water use per capita, we could see that most all of STAN countries are right now in top 20 for water consumers. And the main consumer in this case is agriculture, which basically accounts for 90% of water consumption. And although water productivity has been rising over the years after 1990 and the collapse of Soviet Union, it is still far to catch some of developing countries and, of course, arid countries. And Central Asia, in terms of water security and water availability, is a little bit different compared to some other regions, especially, let's say, more hyper or super dry arid conditions. Water available, however, it is in terms of water availability, it is available through the river discharge, which somehow is not directly connected to temperature and high temperatures and evapotranspiration rates, because most of the water comes from high mountains and a glacial melting. So when the temperature is high, glacier melts faster, snow melts faster, more water available. But at the same time, it creates a condition when too much water is used, and over the course of the river, we will come up with the issues of salinization, of water quality, and water availability, because most of the water used in upstream or in the middle stream are water quality deteriorates. So downstream part have to deal with accumulated problems of whole the region. What I mean by that is we have two groups of countries here, right? Where the water originates, Kyrgyzstan, Tajikistan, high mountains area, and where the water is used in downstream. In Kazakhstan, Uzbekistan, Turkmenistan, where there is a high temperatures, high evapotranspiration rate, and expanded irrigation. So we are dealing in terms of policy with two countries that on one side has a condition for using more water for hydropower, and on the other side, countries that want to use as much water as possible for agriculture. And using as much water for agriculture will develops a condition when lots of water used in upstream, water quality deteriorates, so the downstream have to somehow come with additional condition. And in this sense, we wanted to study how these strategies are different compared to downstream region. In this sense, we did the research in downstream area in Karakkal, Pakistan, which have quite similar, I would not say same, but similar condition as Kızılar'da area in Kazakhstan. And we did the research in the middle stream in Zarafshan River. One of issues is because it's highly studied, although data issues are still available, but it is one big basin. We can study it from the beginning till the end. Previously, the Zarafshan River flowed to Amu Darya, and right now it's totally fully used for irrigation, and some water is additionally taken from Amu Darya River Basin. Okay, so I already talked about salinization conditions that happens because of when we apply irrigated water to the fields. Infiltration happens, the water goes to drainage, and if dissolving all minerals and salts, and if drainage works properly, then we remove that water from the field. However, when drainage doesn't work properly, rise of groundwater happens, and all the dissolved minerals and salts additionally to high temperatures, results in high evapotranspiration rates and creates condition of salinization when soil, especially topsoil, salinize, or so-called salt crust or salt saline or saline soils happens in the upper part of the soil, which is the most responsible for agricultural plants growing and for productivity of the plants. And as you can see, the lands affected by salinization is pretty high in almost all countries. And in some sense, the salinization is increasing over the time due to water shortage in some cases, and additionally high temperatures recently seen and climate change. So right now, 13% of lands in Uzbekistan are severely degraded, and which causes in $31 million losses by land abandonment, but this still have to be argued. If we check the long-term air temperature change in Uzbekistan, especially in Uzbekistan, I will show additional slide in the end if I will have time. And we can see that there is a so-called shift in temperature increase, especially in terms of winter months, and very well observed in the northern region close to former Aral Sea area. And significant increase is seen in Karakalpakstan area for all winter months. However, not that much, like on average, higher than average for a world in terms of 1 degree, but for a winter months, it is very high, in some cases up to 2 degrees warmer temperatures on average in the area of the whole territory. So what I did here, I developed a study framework just to see what will be the water demand and check irrigation water requirement for different crops. So we established different baseline scenarios and tried to assess water availability based on land surface model. It is developed called CBUK, developed by Tanaka, Professor Tanaka in Kyoto University. And we used global available data sets to address water discharge in the rivers. And we tried to analyze the future water availability and also see the crop water distribution, which basically is trying to find out how much water will be available in the future and if it is sustainable to produce the same amount of crops with the water that will be available in the future. And also take into account salinization impact and try to assess what is the water quality, groundwater measurements, and irrigation requirements in the field, because this data is rarely available and very hard to find out. I will not talk today about the model description. However, if you have questions, we can have it. I want to add that the presentation made by Dr. Touge, he will follow me. He will discuss about the model and how he developed it. So I use his model in terms of water estimation for to find out water availability. So as I said, I have 2 basins to do the research on, and those 2 basins, one of this is Shan River Basin. Shan River Basin is also transboundary river. Mainly water originates in Tajikistan, and they barely use it, and 90% of the water is used up until the middle stream, which is around this area when water is not enough available and it's too saline, so the water comes from Amudarya in this way using pumps. So in this area, I try to analyze how much water will be available in future, and there are several crops that people grow here, mainly. Of course, there are much more. And this analysis has been done in 2018. So I tried to analyze wheat irrigation, normal summer wheat, and cotton irrigation, dominant here, and winter wheat irrigation. So those 3 crops. Recently, there has been change in the policies in agriculture in Uzbekistan, and they shift from governmental called governmental push for asking farmers to grow that or another crop to more dynamic different plants grows. And this analysis may just be a little late, but I still want to show you on the amount of water available and how much crop will require, how much water will crops require if we keep the same. So for crops water consumption distribution, we also created a different model for different crops, and we analyze how much different what are different plants growing in the region. We analyze percentage of how they are distributed, and we also try to keep in the model. We cannot know exact amount of water for irrigation, but we know if we keep some amount of soil moisture calculated by the model, we can say that this amount of water would be enough for plants to survive and grow productively, okay? And we take to account all this shown by arrows. We take to account all these variables in our model to just analyze how much water will be lost, how much there is an inflow, and what is irrigation demand. And in the second part, we also did a special water quality analysis in a field. So we traveled along the river and collected different water sampling just to see how this salinization shifts from upstream, where the water quality is quite good because water comes from high mountains, and then shifting to the region, it increases in salinization. And the results show that in the middle of the stream, this already happens in here. So it is quite fast issue in terms of developing, in terms of water quality and in terms of water salinity increase. As you can see from this scale, it grows suddenly and becomes quite and shows quite high values in all the region. And in this region, downstream of the area, water quality somehow drops. And the reason for this is because the water comes from Amudarya and is input to the Shan River Basin, which mixes and reduces salinization in the area. One important case I wanted to mention in here, we did additional analysis in this channel just to see there was one blip in downstream, and we were surprised to see it so early in the region. But the reason for this, as you see, most of the areas are just divided by salinization as just an almost straight line, but somehow in this area, salinization suddenly increased. And it might have been natural flow, but we defined that this was the issue because the issue was until this point, they could keep irrigated water, drainage water in a separate channel. But after, at this point, they couldn't separate the channel of drainage, and it have to go back to the river. Also, it could be from ground floor or directly inflow, and it's because of natural condition. So there is a mountain region here, and water have to flow back, so that's why it increases salinization in this area. Additional analysis has been done for to see the salinization, and many research has been done on this cases, and we tried to see how farmers actually use water, and we found out that in actual irrigation, most of the farmers are using water in cotton fields and vegetable fields and use excessive amount of water. And at the end of the season, you see the blip here, salinization already accumulates. And that happens in normal basin. This area is less salinized, and this area on the right side is more salinized. It's in Karakal, Pakistan with high salinity rate. And the difference between these two examples is salinization here happens at the end of the season. But here you can see when water is applied, this is irrigation. Salinization also rises. That means in the downstream area, salinization of the water. Oh, I'm out of time. Okay, I hope you give me another 2-3 minutes. So salinization of the water increases, and this basically means downstream area deal with all accumulated water, saline water from upstream. This area and saline area basically looks like this. So you can see this salt crust in downstream in Karakkal, Pakistan area. And most of this area is pretty much salinized as seen by this map. And with the help from Dr. Touge, we also try to analyze how salinization distributes over the field of the area. And you can see that when it's not it is not even for the whole field, and increases with the area where the water is not reaching, or where the water comes from down to the drainage area. Okay, so this is our final slide for crop water demand distribution. And in this analysis, I skipped some part where I check and validate the model of water flow. And in this case, we check that this in the first, basically this are the months. So we have all the water available here, and we say that increasing water salinity is not significant when soil is washed in the beginning of the spring. However, when cotton soil washing is applied, it increases and requires a little more water. And then irrigation requirement in May is lower because all the crops, it was already, water has been applied in the previous months in excessive amount. However, with the climate change, we have that the amount of irrigation for water will be increased for 5%. This is just a stable results for relatively low impact. So if average temperature rises to 1 or 2 degrees. And in 2016-80, we are dealing with increase in 70% for water requirement for the same crops that we are growing in the same conditions as now. And you know, this is just the time when we stop everything. We don't increase population. We are using the same fields, and this analysis lacks some of this clearing in this term, but just shows you for policymakers that if there is no change in crops production or in crops productivity, we will be dealing with some problems on the water availability. Of course, this is not new. And in final, my conclusion, I would like to say that water shortage will be well noted due to increasing temperatures, evapotranspiration, salinization of the soils, and requirements of the water to wash it, and will require more water to deal, especially in spring. And summer water requirements could be higher because of high temperatures, and groundwater table may help determine salinity spreading over the area, because right now, just measuring groundwater table is too hard to address. I also would like to note that fertilizer application is not that significant in this area. However, natural fertilizers has been increasing over the time, and chemical fertilizers growing not that fast. And industrial water withdrawal and municipal water withdrawal also increasing, and agricultural water withdrawal is lowering. So maybe in future we can have to address that. There are some issues. Maybe in future, we will need to say that agricultural water withdrawal will catch up with productivity, with high productivity, and we will use less water. So on this note, I would like to stop. I haven't talked about climate change analysis, but it is for a next time. So if you have a question, please let me know. And sorry, I've been a little bit out of time. Thank you. So now yes, Stephanos.
Yes, thanks. I'll probably have a bunch of questions in this group, because actually I have to say that today we have also a lot of students from Water Resource Policy and Management course that I am teaching.
Oh.
So
Okay.
it is also an applied kind of, let's say, educational course here. And we are really very interested in hearing what you talk about. So let me talk in practical terms, in terms of governance and salinization, that it's quite an interesting topic also for Kazakhstan, as you know. In South Kazakhstan, there is a lot of salinization issues. What I heard, and I have been like in some field trips in the south, near Taras, in Kizloda, many people say, agronomists, for instance, don't bother anymore with the saline lands. We cannot do anything anymore. These are already waste lands. So whatever you produce there, they don't have a lot of profit. You're going to put a lot of investments and the return going to be nominal. So what they suggest instead is like, go for some other lands, bring some more water or some kind of agricultural inputs elsewhere, and leave these lands for the years to come, like arable lands. Yeah, don't do anything. There are some others, however, that, as you know, they say, okay, we can restore the lands, we can somehow try to improve this kind of soil composition and make these lands more fertile. And I think that this is a very policy relevant thing, because you invest a lot of money in these lands. And also employment is there. So what's your outcome out of your research?
Okay, so in terms of policy, we can see the two parts, as you said. One is abandon land and leave it as it is, which are happening right now and have been happening for quite a years. Some lands that are not productive, people just leave it. On the other hand, if we are trying to, could we say employ? I don't think. If we try to use additional lands for growing some of the crops, we have to deal with cases of how we will provide the water there. And most of the cases right now, what we are dealing is, and farmers dealing with, we are working in an environment where people use furrow irrigation. It's and one of the key issues here is in using a furrow irrigation, whether it just floods the area. We are coming up with solutions that water that they are applying is already saline. Temperatures are high, so they basically, over the time, they will waste this land again. So in this case, what are our strategy? If the both are basically lose strategy. So there is additional, we have to think about additional ways how we may able to solve this. One of cases that are right now discussed is try to use different plants that can grow on saline lands and use less water. Maybe we will apply water with a short amount, and we try to increase irrigation productivity in terms of using a different technology. Maybe drip irrigation is such a, let's say, such an overused world right now. There are several problems with drip irrigation, especially in downstream area, starting with water quality, starting with sedimentation in the water, and how we can solve this. But of course, this could be one of solution. So I don't think there are some good solution. We have to find out something that is less bad than the other one. So basically, I think development in here will be mostly connected to how well we can preserve soils in terms of salt accumulation, and how well we can reduce water usage in that area. So that will reduce salinity in the area consequently.
Great, thanks, Tim. I would also ask students to, if you like, to stimulate the discussion, because this is your opportunity to discuss with people that they have lots of years experience in the ground. You asked me to bring you people that they have experience in the ground, and these are the people. So whatever questions you may have, especially in terms of salinity, in terms of water use, I think that's the opportunity to have so. Yeah. Thanks, Tim, again.
Yeah, Alia, do you have a question?
Yeah, Dr. Khujanazarov, sorry. Thank you for your presentation.
You can call me Temur, so don't worry.
Thank you. Thank you for your presentation. I have probably some conceptual question. How would you define water insecurity?
Okay, so water insecurity, how we can define it. So basically, insecurity means we are lacking. We may lack this in the future, or some of source that will not be available to us in some capacity, and we have to address this in present for dealing in future. So this might be some question to answer. I'm thinking about how to answer this in a good way, because water insecurity is also a condition of how people basically how people are what are people perception of insecurity. Some may say that in future the agriculture will not play that bigger role, and maybe some water will be available. But in this sense, I think water is in this presentation, what I wanted to show is water insecurity in terms of current operations that we are using in agriculture may lead to issues in the future that will show that water is not as much available. And it's a limited resource that we are using right now. So we have to address it to see, to reduce our capacity in using of it and be able to sustainably live in the future. If I somehow answered your question in this sense, because I think it's a terminology and we can somehow discuss this if it's correct definition or not.
Yeah, I just wanted to know your perspective. How do you interpret? How do you understand? Thank you.
Thank you. So Alisher also want to ask a question.
Timur, thank you for the presentation. Just working with some paper on the international relation, especially of the integration of the Central Asia countries. So we know from the literature that the water question is very tough in the region, and it mostly separate the countries inside the region. So from your perspective in the future, could be the water question be the point of the integration of the 5 Central Asian countries? Thank you.
Well, I'm not a politician, so I'm not really sure how to address this question. I would say that if we are talking about water distribution and the water policy and finding if water can be a uniting source, one point is all of the Central Asian countries right now, most of their agreements on water distribution and water usage are still based in 1990s treaty. So they still couldn't develop any new ideas or solutions how to address water distribution in just this small this inside the basin. Although, as Alia I think mentioned already, there are some sharing between the countries in terms of energy and water release. And of course, for downstream countries, we have to think about this for, I think they both have 2 different strategies to win. And downstream countries will basically say, if we don't do anything, water will still flow. And upstream countries are arguing with that. So this is pretty much connected to political will, I think, for right now. And in terms of how countries will decide to address it, will probably be connected to the development in the region. If most of the countries can develop and will develop in a good economy, then agriculture will be reduced and water usage will also be reduced. So I may see that in some time in future, all the countries will have some united solution for all the water questions. Yeah, I hope I answered your question.
Oh, thank you. But one clarifying question about this. From your perspective, these future solutions will be comes from the out of the region, for example, from the grants of European Union or with the help of Russia, or it will be the solution of in regional connection between 5 Central Asian states. Thank you.
Okay, so yeah, I will answer this question, but this is the last question because we are out of time. Actually, I think it will be from inside with moderation from European countries. Why it will be from inside? We could see that when there is a political will, most of the social or economical question could be solved. And we saw it with, for example, Uzbekistan recently, when until 2016, they had this argument with Tajikistan and Kyrgyzstan and couldn't solve the issues. The borders were closed. There was a visa requirement and so on. And suddenly, in a couple of years, they agreed for Rogun, they agreed for opening the borders and like easing the tension between the countries. And we are living in the same region. We have the same environmental issues for like environmental issues are not separated just for one country. So it will be the big issue for all 5 countries. And I think it will come from inside. Anyway, thank you very much for all your questions.
Thank you.
I took too much time. So I'll be moving on to give a floor to Dr. Touge from Tohoku University. We have been working with him for quite a while, and he has a very long experience, more than 10 years working in Central Asia. And Touge-san, please.
Okay, thank you very much. So firstly, let me share my screen. Okay, so as Dr. Temur mentioned in his presentation, my presentation is about physical modeling for water balance analysis in the whole basin. And I prepared a video, presentation video, so let me share the video to you. So let me start it. Hello everyone, my name is Yoshiya Touge from Tohoku University. Today, I'd like to talk about this water balance analysis in the Aral Sea Basin considering irrigation activity and its scenarios. Here's my target region, Aral Sea Basin in Central Asia. As you all know, serious drought was occurred in this basin, and it is famous for desiccation of the Aral Sea. This drought was induced by large-scale irrigation project in 20th century. In the Amu Darya Delta, located in Karakoram, Pakistan, about 90% of the rice crop and 75% of the cotton crop were lost when the severe drought occurred in 2000 and 2001. So in terms of the food security, or maybe we can say security of local economy, we need to evaluate future water resource and water demand considering potential adaptation and future climate change. Since most of the water resource is supplied in mountainous region in Kyrgyzstan and Tajikistan, and most of the water is consumed by lower countries like Uzbekistan and Turkmenistan, to evaluate this water resource and water demand, we need basin-scale hydrological simulation. So in my presentation, I call these water resource and water demand as basin water balance, and try to evaluate in hydrological way. So this slide is to show the concept of a hydrological approach, terrestrial water circulation model. As shown here, the word of water circulation include many processes in the Earth, but our target is from rainfall to evaporation on land. This is what terrestrial means. And we are trying to analyze these processes by physical models. So once we validate the model, we can use it for future projection or virtual scenario analysis. Here, in the Aral Sea Basin, the thing is evapotranspiration irrigated farms here accounts for a large proportion of total evaporation in whole basin. Therefore, our model should consider such a human water operation. Here's a challenging part as a large-scale hydrological simulation. Utilized hydrological simulation was mainly by land surface model Shibuk. It can calculate vertical water and heat balance together, so evaporation and transpiration can be accurately calculated. Since this land surface model is only for vertical analysis to calculate how much water evaporates, flows, and be stored, so after calculation, surface runoff and groundwater recharge will be accumulated as a water resource. One of the strong points of this model is it can consider irrigation in each mesh. Minimum soil moisture here is set for each crops, and if simulated soil moisture is lower than this minimum values, water is additionally supplied to the surface. And this minimum soil moisture is prepared for each crops and each season. Furthermore, as shown in this right side, now I can consider difference of furrow irrigation and drip irrigation. This is to consider the application efficiency for the irrigated farms. Between them, the way to supply water is different, so evaporation loss from surface can be considered. However, irrigation activity is decided by local people. So this means the irrigation regimes. So it has many uncertainties in this model. In this case, we need to validate or we need to investigate how the farmer operates the water in the farm. So we need observation or investigation for our validation. Therefore, we performed in-situ measurement of soil moisture in several sites in Uzbekistan. The site here is Kyrgyz and the Vivut site in Karakara, Pakistan. In this research, I will show you the result mainly in Vivut site. This Vivut site is located in middle stream of Sirdarya River Basin, and utilized sensor was here, a wet sensor, using the TDR method to measure soil moisture and salinity. And here is the result in Vivut site. Vivut site is mainly for cotton, sorghum, and wheat. And here is the result of soil moisture. And it has irrigation frequency. As you can see, we have the irrigation every 2 weeks, and this frequency is very important to validate our models. So here's a comparison between observed and simulated soil moisture in Vivut site and Kyrgyz. Frequency of irrigation was every 2 weeks, so I calibrated our irrigation scheme, and the frequency is now almost same. And the simulated annual water requirement for cotton was now 700. And here's a further analysis. Red line is evapotranspiration, and green one is a transpiration. So difference between these two lines are water loss due to evaporation from water surface and not by transpiration. And this is the application efficiency. And this is defined as the rate of irrigated water used by transpiration. And this means 54% was actually used for transpiration by plants. So this simulation can consider even water use efficiency in the farms by physical simulation. This slide is to show the accuracy of my model briefly. The left side shows the annual river discharge, and the right side shows the desiccation of the Aral Sea. Both of them were accurately analyzed, so it will be accurate enough to evaluate some scenario analysis and future projections. Here are virtual scenarios for drought adaptations. We evaluated 3 types of the scenarios, and the first was about irrigated area. The first scenario is for expanded irrigated area after 1960s. As you can see here, the irrigated area expanded almost twice after 1960s. So 0% scenario means the irrigated area was not expanded after 1960s. And 50% scenario means that only half of expansion was assumed. Actually, this is control run to show the relative impact to the further scenarios. Because since we know such increase of irrigated area had significant impact on the whole basin, right? So if the latter scenario will have the comparable impacts, we can say, we can imagine how big it will be. The second scenario is improving on-farm irrigation efficiency. As I mentioned before, our model can consider the difference between furrow irrigation and drip irrigation. Since the drip irrigation supplies required water continuously, it can be regarded as a minimum required water to make the crop survive. So in this scenario, we can see the impacts of how evaporation loss in farm will have the impact in the basin scale. The third scenario is for transport irrigation efficiency, the channel irrigation efficiency. In my current reproducing analysis, I assume the channel irrigation efficiency is 40% based on the local report. This means 1.5 times of the supplied water to farm is lost in the transportation processes. So this scenario is to assume if this transport efficiency will improve to 40%, 50%, or something. And here is the results. In the all scenarios, I calculated how much water can potentially saved if each adaptation plans will be performed in the whole basin. And just to show the impact, I ran ROC desiccation model for each scenarios like this. For example, in the case of the drip irrigation here, annual potential water saved is around 16 gigaton, and it will make the changes of the ROC much larger, like this. Even in 2000, the ROC's level was around 1976 level. And even in improving channel irrigation efficiency here, will have the significant impact. Even 10% improvement will save 12 gigaton water annually. And this is comparable result with 50% expansion scenarios like this. I know this scenario is all impossible, but such a quantitative analysis is important to understand the potential impact of each adaptation directions. And since I showed only basin scale results, but if we can find sensitive region in basin, we can focus on the region to improve irrigation efficiency. So for further slide can show the sensitivity of the future projections, future climate changes. And here is scenarios for future climate change. Utilized model for projection was Global Circulation Models, MRI-GCM. This is Japanese model providing high resolution globally, and it is 20 km resolution. It has 3 calculation periods: present, near future, and end century. Right figure is long-term average of annual precipitation. As you can see, it will increase in mountainous zone, and almost 10% increase was projected in this region. This increasing trend of precipitation means water resource will increase. However, on the other hand, temperature will also rise in entire basin. As you can see, our temperature in the future will be 4 degrees higher than present climate. So one side, since precipitation will increase, water resource will increase. But the other side, higher temperature will make evaporation increase, and it also increase water requirement in irrigated area. So we need to quantitatively analyze basin water balance using physical hydrological models. Here is a result of basin water balance. This table firstly shows the changes of the total water resource here, and it will not change so much. Even though precipitation will increase, but increase of evaporation is also significant, so the increment of precipitation will be consumed. But this IWD, irrigation water demand, it will increase around 10% in whole region due to higher evaporation intensity. This means crops need to drink more water to survive under future climate. Therefore, in conclusion of this model, water scarcity will be much serious even if we will not change irrigated area by climate change. And here is a distributed difference of irrigated water demand. The positive mean water requirement will increase. As you can see, Amudarya Delta region here is one of the regions where irrigation water requirement will significantly increase. Here is a time series of soil moisture, present and end century. As you can see, in end century, irrigation frequency should be higher to keep soil moisture. So this means that this region is a sensitive region against climate change. So we need to quantitatively analyze the suitable adaptation plans for such kind of regions. So here is the conclusion of my analysis. Thank you very much for your kind attention.
Okay, thank you very much. So,
hello everyone. My
I'm so
name is
sorry.
Yoshiya Touge from.
Oh,
Thank you very much.
thank you very much, Touge-san. I actually wanted to listen to it again, but let's stop it here. The floor is open for questions. It was a really, really great presentation by Dr. Touge. So I hope you have lots of questions to him too. There. No questions? Okay. Oh, okay, Stephanos.
Yeah, I may open the floor, guys. Okay, because I think that was probably for some of the students probably a bit overly technical, but I think it touched upon some good points. What again from the Polish perspective, what I'd like to ask, you mentioned in the last slide, about the drip irrigation and how much water would be saved, right? If this would not, let's say, become like in a furrow irrigation, and how much we can have for Aral Sea. What I would like to ask you is that many people now, they discuss, especially from Uzbekistan, we know that there is a big initiative from Uzbekistan somehow to not to bring back the water, but somehow to revert a bit or mitigate the dust and the problem we have with the dust all over the place. And we have the Saksaul and etc. And we have discussed also in the class. What happens with the water that we could probably bring back from the rivers to the environmental flows, let's say, or the water that would bring from the rivers to the Aral Sea? Yeah, because We discuss about rationalization of irrigation. We discuss about how much the agriculture could be like more beneficial, but we do not discuss much on how much water we could release back to the rivers. So to have natural flows and somehow having some restoration. And you know about World Bank now discussing again on the phase 2, phase 3 of Aral Sea, how we can make the North Aral Sea a bit bigger, how we can probably try to mitigate the issue with South Aral Sea. So I would like to ask the presenter, is there any kind of, let's say, sideline of understanding in this regard on the environmental flows in parallel with the irrigation that was the analysis about?
Okay, thank you very much. Our land surface model can consider the total evaporation from the sea. So if we have some strategy until which level we need to recover the ROC or we need to stop the ROC desiccations, in this case, we can calculate the expected evaporation related to the ROC area. If we decide this evaporation, total evaporation, in this case, we can use it. We can consider it as a water required, amount of water required for environmental flows. If we know such a amount of the environmental flows, using our irrigation schemes, we can calculate the suitable irrigated area. So we can plan the area using this model. But as you mentioned, how much water should be returned from the farm, right? In this case, such kind of process cannot be considered. So in this case, we need to change our model, I think.
Yeah, I'm asking and following up, sorry, because, you know, there is now a lot of discussion about these environmental flows. And as you said about the evapotranspiration, and you present, for instance, the cotton, right? That you have like 800 millimeters and nearly about 700 millimeters, it goes evapotranspirated. Yeah. So how much it goes to the root zone, it's not that much. How much goes to the crop itself? Because you have a high evapotranspiration rate, right? So the next question again comes with the global price of cotton that we have nowadays, yeah, in Turkmenistan, in Uzbekistan, in Kazakhstan. How benefit is to still making these cultivations, given that we have the problem in the Aral Sea. Everyone talks now about the Aral Sea. It's very difficult to bring it back. And still we're producing cotton that it nearly the same water that you put, it evapotranspirates. It goes to the air, let's say.
I see. But yeah, maybe.
So you think it's worth continuing, like, I mean, going for other, as you said, like other ways of like drip irrigation or more sustainable? Do you see that like as more sustainable practice?
Yeah. If we want to continue the irrigation to the cotton, in this case, we need to think about some more much efficient way, right? But in the same time, yeah, there are.
Stephanos, may I add some point in this concept?
Sure.
Yeah, I would like to note it here that in my presentation, and the end, so it will be the answer on all of your questions.
Okay.
Thank you. I'm really looking forward to hear that. Thank you very much.
Yeah. I also would like to add to everybody asking the questions on the policy or how to use Dr. Touge's results. I want to point you to the fact that he could use a model to reproduce the same physical conditions in the region. So what he basically is trying to say is that using this model and using different strategies, as Stephanos suggested, we can calculate or see the outcome results. So it could be as a model or as a tool for policymakers to have some discussion. I don't say that they will definitely discuss or take that solution, but they may change their mind in some way. So Diana has a question. Please go on.
Thank you, Professor Touge, for your such enlightening presentation. And I want to ask you about the reorganization of irrigation infrastructure. What efficient technologies we can use for the use of water resources at close water deficit?
What kind of the
Should I repeat my question?
to make the water use more efficient, you mean?
Yeah, in the regard of reorganization of irrigation infrastructure.
I think that there should be so many ways for irrigation structure, but since our model is quite simple one, so what we can consider is quite limited actually. So actually I'm not quite I don't know quite deep understanding of the irrigation in the local farms. So there should be some more way to make it efficient. But what I can consider here is just drip irrigation and furrow irrigation.
Thank you.
Touge, I just wanted to add that continuing to Diana's question, I want to point to scenario 3 in Professor Touge's presentation of canal irrigation efficiency. So what basically that means is right now we have distributed channel system, and this channel system are not lined. What I mean is they have basically the ground system. It's just channels that are digged in the soil. They don't have lining in terms of cement or kind of covered one. So a lot of water is just infiltrates inside the soil, and we lose like up to 40% of that water. So just by improving this small part, using Professor Touge's calculation, we could have had a level of RLC in 2000 equal to 1985, right? If I'm correct, Touge-san. Yeah. Okay. Thank you very much, Alibek. I'm very sorry. Can we move your question to the end? So I'm not sure we will make it in time. So if we have some time at the end, I will open discussion again and we can continue on. Sorry. So we will move on, and next presenter is Sanjar. Thank you very much, Professor Touge, for your presentation.
Thank you very much.
Sanjar is a PhD candidate in Kyoto University, and he's doing research in Kyrgyzstan. Sanjar, the floor is yours.
Yes, thank you very much. Can you see it?
Yes.
So, hi everyone. My name is Sanjar. I'm a PhD student studying in Kyoto University in the same research unit as Dr. Khujanazarov, but I'm working more in the upstream areas, particularly for the water resources modeling. And today I'd like to make a presentation about meteorological data importance and policy challenges in mountainous regions of Central Asia. So I'd start with a little bit of background of my research, and then cover the current situation of meteorological observations in Central Asia, how, let's say, the ground researchers' challenges with the data, impact on practical use in water systems and modeling, and role of the government and policy building in the data policy, and some examples of interaction in different countries. So, as you may already know, as a consequence of the climate change, we have a global temperature rising trends, which leads to the significant and faster degradation of glaciers in Central Asia. So you can see this representative glaciers in Kyrgyzstan, as well as, for example, this one, Tuyuksu in Almaty, and other glaciers significantly shrinked for the past 50 years. And if the trend continues, probably most of the glaciers will disappear by the end of the century. So assessment of glacier degradation due to climate change is a crucial task to mitigate the impact of water stress in the region. Especially when the glacier melts, it leaves glacial lakes, and it can be much bigger So potentially causing the outburst and cause flooding to the downstream areas. So this is also kind of the upcoming disaster challenges. And at some point in the future, when most of the glaciers melt, the annual runoff in the basin will be reduced by some percentage, and probably we'll have more water stress in those glaciated regions. Especially in Central Asia, where the mismanagement of water resources can lead to significant anthropogenic disasters, such as the shrinkage of the Aral Sea. It's very important to properly calculate the amount of water that we'll have in the future. So society is likely to seek verifications that policy ideas are based on the evidence provided by scientific data and information, because climate and environmental change can be contentious in the policy arena, and the demands for actions are especially strong. And as for scientific data and information, it's mostly based on the observational and other data. So for the current situation of meteorological observations, I guess most of the post-Soviet Union countries are also affected by it. So after dissolution of Soviet Unions, the financial budget for the meteorological observations has been cut, especially in Kyrgyzstan, and the number of meteor stations dropped significantly, especially in the mountainous regions. As you can see, many of the stations were abandoned. And if you take a look at this distribution of the meteor stations by the altitude, you can see that above 3,000 meters, there are almost no meteorological stations, while most of the region are located above 3,000 meters. So new automatic meteor stations are installed in mountainous areas almost every year with the help of international scientific organizations and government support programs. For example, these meteor stations were installed in the mountainous regions in Kyrgyzstan with the help of Kyoto University. And this station was installed right on the glacier. So we have a continuous observation and input data. So another challenge of these maintenance areas is that it's hard to access the places and hard to maintain this continuous monitoring. So you have to go every week or in a daily basis, go through the 1 meter of snow and collect the data. And another problem is the validation of manual and automatic observations, because you can't go almost every day or every week. You have to install some automatic observations, but at the same time, you have to keep your manual, old Soviet Union style data observations consistent with the automatic observations. And most of the historical data that we use in the modeling or other predictions are in hard copy archives inherited from the Soviet time. And it takes a huge effort actually to digitize it. So you have to go to this hard copy archives and like digitize it through to your Excel or whatever you use. And it's a very huge amount of data. And another problem is the deterioration of old Soviet equipment. For example, this temperature measurements, you have to, if you want to use new automatic observations, again, as I said, you have to make it consistent with the old observations. And in practical use, usually for the modeling purposes, we need input data, and especially important are temperature and precipitation for water resources modeling, as well as other variables such as radiation, humidity, air pressure, wind, and so on. And using this kind of models, you can get the output and results and predict disasters or various processes such as floods, droughts, glacier degradation, irrigation demand, as previously mentioned, and so on. So in this purpose, we use various models, conceptual, physical-based, and so on. And we need data, especially important in situ data, so we know what's happening right on that area. And if we don't have enough data for that region, especially in mountainous areas, we use so-called global precipitation products. It's satellite-based or based on the observations, and it can be useful for modeling applications in ungauged areas. But some of them are not accurate enough or needs additional assessment and proper downscaling. So for example, if you take a look at this Aphrodite precipitation data, these dots are the included meteor stations in this data set. So in 2005, we have a full coverage of the Central Asia. And in 2008, almost no any observation stations included in this data, which lead to significant bias. If you take a look here, like there is a proper trend for the cumulative precipitation, and then it's just inclined to lower values. And inclusion or absence of meteorological stations in data sets can lead to significant bias in precipitation products, as well as for the other products such as European reanalysis and so on. So for the modeling purpose, in my research, I used various precipitation products and compared it with each other in the Issyk Lake Basin. So Issyk is endorheic, it's closed basin, so there is no outflow from this lake. And it's very useful to estimate the accuracy of the precipitation products. So I used various precipitation data, such as, and you can see that some of the data, for example, this Japanese reanalysis can overestimate, some of them underestimate, and the proper data set has been made by inclusion of the observation data. So global products are very useful for ungauged basins, and its accuracy can be improved by inclusion of in situ data. However, performance of the current reanalysis precipitation data is far from ideal in high altitude Central Asia, and future development should be focused on expansion of monitoring system and incorporation of additional observed data. So from the previous slides here, I used included observed in situ data in existent precipitation product. So here's the original Aphrodite data set above the Issyk Lake area. And here's the modified with included in situ precipitation station data. And it significantly improved overall representation of precipitation over the region. So we were able to properly model the water balance of the lake. So as I mentioned before, it's very hard to get this kind of in situ data, and most of the Central Asian countries seem to be focused on national activities and restrict themselves to exchange national products for research purpose. And at present, the global data exchange is limited to several manual stations from national meteorological agencies. For instance, Kyrgyz Hydromet is the Kyrgyz National Meteorological Agency, is required by law to charge any use of the data. The pricing is fixed by the Anti-Monopoly Agency of the Kyrgyz Republic. So for example, to get this kind of data from these stations, I had to pay a fixed amount of money from my pocket to do this kind of research, but I didn't. So it's a secret how I get it. And while the global observation network compliance is not achieved at present, measures have been taken to enhance data exchange with the goal to become GBON compliant. On the other hand, current data sharing policies are restrictive and don't promote free and open access to meteorological data. And also another problem is that in these agencies, meteorological agencies, academic training in the field is limited in terms of climate sciences, and consequent shortage of specially trained staff is challenging for Kyrgyz Hydromet to contribute to this institutional coordination mechanism by providing scientific specific climate services in support of public policies as well as mitigation and adaptation measures. So overall, to handle this kind of problems, I think the future policies should be focused on building the scientific capacity in the governmental organizations and to provide more open data access and exchange between users, and also institutional coordination mechanisms so the government can do this kind of coordination in data exchange and other processes. For example, in Japan, they have like a beautiful system with this AMIDAS data. It's a system, observational system network covered by this observation meteor stations. And you can freely download it from the government website and use it for your purpose. And the data is used by various stakeholders, including scientific organizations, government, academia, and global institutions. And another example is, for example, this National Ocean Atmospheric Agency in US. They provide this kind of data, and they provide also space-based environmental operation remote sensing products to make improvement in weather, climate, and ocean assessments and predictions possible. So in these countries, governments also not only collecting the data, but also providing some kind of products to be as a tool for policy making. So in conclusion, I'd say that data collection and management should be institutionalized, so they don't depend on occasional or project-specific funding of scientific research. Intergovernmental cooperation is needed to freely exchange observation products as well as assessment results. Strong scientific capacity is a key to develop evidence-based policy decisions in order to mitigate upcoming changes. Scientists should be recognized and rewarded for establishing data sets or data collection efforts at the nexus of weather, climate, and society, and collaboration among scientists and governments will not only benefit over time data collection, but will also enrich both research and policy in the future. So thank you very much for your attention. Yeah, I'm ready to ask your questions, or if you have any insights in terms of policy and data sharing, yeah, I'd be grateful to get it from you.
Thank you, Sanjar, for your nice presentation. I will be having a couple of questions, taking a couple of questions, and then we will move on to the next presentation. So does anybody have something to add? Yes, please, Alia.
Hello, thank you for your presentation, Sanjar. Actually, the situation in Kazakhstan is similar like in Kyrgyzstan, where we need to buy data from Kazhgidromet. And my question is, how do you think why, for example, in Kyrgyzstan, you said that by law, it's prohibited to share information, the data. What are the reasons? For example, I know that in Finland, like you also showed, like in Japan, in US, anyone can use the data. And why in Central Asia, or for example, in Kyrgyzstan and Kazakhstan, the situation is following that we can't. And even organization, even within the country, like state organizations should also buy, or it's difficult for them to exchange the data? What are the reasons?
Well, I think like there's several reasons. First of all, particularly in Kyrgyzstan, the financial budget of the meteorological agency is low, and they expect to cover this kind of observation spendings through this data selling. And another reason, I guess, it's like inherited from the Soviet time that you have to keep the data in some kind of secrecy, or like whatever use covered by the let's say like intelligence agencies and so on.
Yeah, okay. Yeah, Alibek, please.
Thank you very much. I probably, can I use this opportunity to ask a question from Professor Yoshiya from the previous session, the previous presentation?
Sure. Okay. I would have left some time at the end, but yeah, please go on.
Right, okay. Just to support what Mr. Sanjar already presented, but my question is about Aral Sea. When we're talking about Aral Sea, we're saying that we are not trying to recover the volumes from the past periods, but we're trying to save the current volumes. And the current volumes currently impacted by the irrigation industry in Central Asian countries, four of them. My question, so if we know the root cause of the Aral Basin problem, do we have some data whether these four countries, except Kazakhstan, are making some effort to diversify the industry to replace the irrigation economics towards something else? Because, for example, if we use the experience from Israel or Mexico, they had similar problems, but they they tried to solve that through the prohibition of the water usage by establishing high tariffs or monitoring the level of water use. So are we making some efforts in those four countries, our neighboring countries? Like, are they changing their I would say strategy and policy in their economics? Thank you.
Thank you very much. As for water usage, as you mentioned, it was so difficult to obtain the data. What I found, firstly, I do some measurement, soil moisture measurement directly in the irrigated area. It should be one of the important data, but it was obtained by ourselves. The second one is what I found in the Ikarda in Uzbekistan. I have found some irrigation regimes. It's kind of manuals of the irrigation. I use it for model validation. What I can use was only two types, but what I need at the time is water required for some specific regions, total water use. Well, such kind of data, we couldn't use it. So as you mentioned, I'm still need such kind of data, and my model still needs some validation.
May I add some things related to RRC?
Yes, please.
Very ambitious question, actually. But all of the, I think, global community now, it's waiting when RRC will come back, or at least to keep on the current level. That it's really very good question, and I would like to tell you that I don't know how government is putting together efforts, but there are a lot of water in the deltas of the rivers, especially drainage water. A series of artificial lakes, because RRC, by drying up, doesn't disappear completely. So it was just divided in series, a little bit of mineralized water that could be used for biomass production, for different alternative production. And this is a little bit costly. And nobody has good policy. There is no special integrated management action plan on the behalf of the government itself, national level, and transboundary level. So there are a lot of water. Actually, we can't say that there is no water there. So the problem is who will be so smart to find a solution, how to orient it, all this drainage water. For example, I work a lot of years in Jiltarbas lake system like Sudochi and others, and it sees a lot of water. We had in past a very good example of a World Bank project that oriented this channel. I think it is Amudarya channel or some Kungrad or something so, and it was work actually. And also from Kazakh side, you know that you already rehabilitate part of Aral Sea. So there is in place enough resources, and nature is very clever to self-regenerate. The problem is, again, good policy, good strategy, and good academic Sanjar, I really put a note, academic professionals. It should be an integrative management action plan, long-term action plan. So sorry.
Yeah, thank you. Actually, I have a question to Stephanos. I am a little bit over time. Would you give us additional 5-10 minutes?
It's quite difficult, Timur, but
Okay,
let's keep it on.
Okay, Darin, I see your hand, but we are a little bit out of time. Let me take a question later if we will have time, or you can type it in the chat and we'll try to answer. Thank you. So I'll give next presentation is by Professor Toderich. Professor Toderich, please. We cannot hear you. We can see your presentation, but we...
Kristina, you have to unmute yourself.
Okay.
ミュートになってますね。
Yes. It's mute.
A list of participants, and as a
Yes.
co-host, you can mute and unmute people.
Yeah, with the unmute, unfortunately, Ricardo, I say ask. It says the option ask to unmute. I can mute, but I cannot unmute.
Okay.
そういうことか。
Sorry. Now I.
It's okay. With
Kristina,
this, I
the presentation
managed,
is
but
not
how is with screen? I didn't manage. I don't know.
Okay, we don't see a screen yet.
I don't know how to share. It's telling me that. Okay, what about now?
Sorry, probably
no.
you should stop.
Oh, okay. Yeah. Okay, we can see your presentation. Could you go to present mode?
Okay, let's go.
Maybe slideshow. Slideshow,
okay. It's not going in my case. I don't know what is happening because a few minutes ago,
yeah,
like this.
Okay, yes.
Yeah.
Finally, guys, this means old generation is continuities between generation. And good afternoon. And I would like to tell you that our session and my presentation is just a logical prolongation or continuous of our previous presenters. And this is because we are lucky this year. For the first time for Central Asia, we win a very big project. We call it Satraps project. This is a kind of interstate between two states bilateral 5 years project of research, development, and education. So that it gives us a good opportunity to combine all these approaches. For example, go from fundamental research to development and through education. And all this will be a very good background platform for the policymakers and of course, stakeholders, decision makers as well. My key hypothesis that I would like to talk to you today, we need to think very seriously how to live with salinity. We need to learn how to produce much more food today from saline lands, at least in case of the Aral Sea Basin countries. No other solution. So, since climate change is changing, as my previous presenter saying and justify clearly, then agriculture and food system must too. So here I would like to tell you about institutional framework for saline agriculture development. And I don't know if I will have enough time because it's on the end policy, legal and regulatory framework, institutional and capacity building related to this one. As I mentioned, it should be a special integrated action plan at all levels, from global to national. And very important, in order to find a new alternatives agriculture development in the region, donors' financial asymmetry, and also governmental funding. Because it's true, farmers will not afford this saline agriculture. One of the reasons why still we are in place with this alternative and future agriculture development in the region is because everything is on the shoulder of smallholders, farmers, householders, and also in remote areas. From your information, farmers doesn't have a right to use these marginal lands. We didn't have yet any legislation, law, how farmers should use these marginal lands. And in this concern, of course, I would like to go to tell you that one of the key elements to which we should pay attention is agrobiodiversity documentation, so inventarization, preservation, and sustainable utilization. Why? And we need to go not for simple saline agriculture. Why we need all this science and technology, higher tech technologies that three guys inform us today. We need it extremely urgent if we would like to go to the saline agriculture development. And it should be digitalized, it should be computerized, it should be a lot of work to make awareness and to make a capacity building with local communities who is responsible to produce food, fibers, technical products, biogas, anything, alternative products for such categories of wastelands. And if you look in here, I put this map specially to show you a very interesting things. Looking, we are located in the area from Gobi, Taklamakan, into Irano-Turanian lowlands, Aralo-Caspian, and to North Africa, if you would like. So we are located in a special region. We call it cold, Central Asian cold desert belt. And for your information, Central Asian desert, this belt, as you know from the concept of science of Vavilov done, it's a center of origin for so many agricultural crops. Who from you is telling me how many years was passed until potato came on our tables, until cotton came on our fields, wheat came in our fields? So it seems that now we are in front of neo-domestication process of agricultural crops. How sad it might be for the governments, for the policymakers, for the people who get enough money now for the cotton and from the wheat. We can't rely on wheat and cotton anymore when high saline land is concerned. We should go for such kind of crops. Even everybody thinks that these crops is the best crops. No, each of these crops has a meaning in the nature, has an ecosystem service meaning. And all of these crops might have a utilization. And for 25 years, I am working to find out what halophytes, it's a salt-loving crops, salt-loving species. Fortunately, I would like to Central Asian flora is the home of more than 1,000 species. Among them, a lot is commercially oriented species. The problem is that there are no academic background so far, because also the time that was a very, very famous specialist on halophytes, now it's not in place. I would like to stress a little bit young generation, because young generation started from 1990 or after the collapse of Soviet Union. So we start to put much more investment in education related to agricultural economies, to modeling, etc. Everything is great, but we forget about fundamental science, real science from the region. And I think now we are in phase to combine all science. And it's an interactive, integrated approach to go ahead. And here we developed already the salt tolerance scale or limiting of thresholds from all the crops. And we find out that these halophytes might be of sense. This is the main idea in our SATREPS project. And this SATREPS project is consider several strategies, even policy and social impact, because we have already enough science to go for the neo-domestication of these halophytes. We know how to introduce them into traditional system, how these halophytes might benefit traditional crops. Actually, even in a wheat-based system, we'll find a solution. But before giving some commercial value for halophytes, we need to have some successions, because salinity it's too going too severe, it's too serious problem. So we need to have some successions. So how to move into this non-traditional agriculture, and how we find a solution to not to ignore, but at least to manage this leaching. We need to stop our farmers to use so much water for leaching. In Pakistan now, actually they use huge amount of water for 4 or 7 times for leaching. And I would like the chairman to tell me when I should stop, because I can't do it too much. And today,
we still have 4 minutes.
Okay, 4 minutes is enough, not enough. But anyway, I will give you some ideas, and maybe it's such a response to one of the questions that was addressed, which kind of technology might be as benefits from saline lands. First of all, it should be the agroforestry production system. And this agroforestry production system, it's multi-purpose production system. So these trees should be, but here you need to know landscape geometry, how you can put all these trees in place, because between trees, you will have some cash crops, but not cotton, unfortunately. Because you see, this agroforestry might reducing topsoil salinity and increase soil organic carbon stocks by 35%, especially if it's diagnosed that it's a azote fixation, it's not legume, but it's azote fixation. So I would like to tell you that all of these halophytes has a very interesting mechanism to survive in saline environments. What is new for this project? In our project, we will try to mobilize, and for the first time in Central Asia, Tottori University will initiate, we already working for 2 seasons, and the ICAS, this is International Innovation Center for Aral Sea, under the President of Republic of Uzbekistan, and we receive approval from the government of Uzbekistan, and Ministry of Innovation is also keen to put some investment, and we are going for the first time establishing of gene bank of new salt tolerant, drought and heat tolerant crops, and of course halophytes. And we have in place already very interesting data and crops and seeds as well. And one of the key elements that might reduce salinity, might reduce water use, might reduce leaching, etc., it's spring wheat. So we need to make for promotion of spring wheat technology. That means in autumn, before leaching, we make the industrial plantation of commercial halophytes. After that, in spring, we will go for this spring wheat, and using new germplasm, not genetic modified. Please be clear that this it will be new genetic improved lines from the gene bank of Japan transferring to Central Asia, and from different international nurseries like CIMIT and others. And another activities that we need to have in place, and we already introduced in the region, is genomic analysis for food security. And it will be a special university, MIA University, doing screening of all these wild species from dry bottom of Aral Sea, from all these deltas of the river, only in Amadouya, unfortunately, but we extrapolate later to Sirdarya Delta in Kazakhstan. So we are going to make this isotope analysis screening of these wild relatives that might be transferring of genes, salt tolerant to traditional crops. And also it will be very good platform for neo-domestication of those crops that some of you needs is best crops. Nothing best in the nature, everything it's good. And why we are going to introduce these biofortified staple crops like quinoa, amaranthus, and the others? This is because they are really very salt tolerant, and also all of these pseudo cereal crops, we call it pseudo cereal crops, are very rich in protein. For example, if human cells can produce only 10 amino acids, in these crops we have 20 inside of the seeds. And what we are doing now, we are trying now to go for biochemistry analysis of these metabolites to make sure that under high saline environments, these seeds might be produced, consumed by children, by human beings. This is quinoa. This is a new crops in the region going extremely well. A part of quinoa, today we have 42 crops. Excellent, don't worry. But what is a challenge for policymakers and for all of us? Challenge is that we don't have no knowledge, almost no knowledge, even in institutes, in universities, in school, with farmers, with householders, how to make these seeds of good quality. And here we develop this methodology, how to work with small, medium farmers. And today we work with almost 200 farmers, and we develop this social network for seed production. But this, it's still under disputes, and it's still under debates, and it should be a lot of reforms or a lot of transformation, not only transformation of food that recently was mentioned by the General Secretariat of OON in the United Nations, but also reforms completely on the national, regional, and global level. And so this quality control is a key element as well. But what is very important in terms of regional integration, and exchange of seed, so it should be a special legislation, a special approach to develop such kind of agreement between countries for material transferring. So this certification quarantine that we have from Soviet time should be modified, optimized, and working, like they have now optimized meteorological station. Why? We are not optimized all this seed production system. For our farmers, it's easy to go to buy some seeds from Netherlands or from other countries or from international nurseries, CIMIT, Icarda, IGBA, etc. I would like to tell you, I was 20 years with IGBA, but I don't like that our farmers will rely on international seeds. We need to develop national system of seed production. And this is my almost last slide. I have a lot of slides. I have a lot of business models working well on saline lands, but I don't have time. But I would like to go for this agricultural land economics cost analysis and net incomes analysis. And it should be some socioeconomic analysis and clearly cost before what each piece of marginal lands is going for saline agriculture. We need to know the root causes of this degradation. We need to know which is the reason. This is the reason of mismanagement of farmers, or if he is low qualified for such kind of managing degraded lands. It might be this land is dead lands, irreversible, like we are going, person has a cancer, going to the doctor through tomography, it's an, oh, sorry, it's the last stage. So it's the same as last stage with Aral Sea Basin. We have dead lands as well, but there are series of categories of marginal lands that could be used. Also, we need to empowering smallholders and gender vulnerable groups. We need to work with these people. They are sensitive, not because they would like to be sensitive. They are sensitive because of access to different sources of knowledge, technology, investment. And here, I would like lastly to mention, we need to think about asymmetry of government investment and donors funds. This is really, really very important. And it should be interactive. This is why we need all the approach that our speakers on my session today mentioned. We need to have an interactive interface, manage to mapping, I don't know, strategies of using all this data, transferring it into the field, transfer it into the farmers. Now everybody has mobile telephone. We need to develop different applications to make access to new information, to new knowledge through development of so-called regional, maybe multi-sites testing and demonstration, much more demonstration. And in this, I have a lot of agro-business models that I'm not going to it.
Don't have
No. Just I take one sec. So we need to find in order to agro biodiversity mainstream from marginal lands and to produce foods from saline lands, we need to have policy framework and interplay of relevant institutions in all Central Asian countries, including agro-biodiversity preservation and storage. Interstate transfer agreement or commercial germplasm, any bioresources, not only plants. Joint global regional field mission for documentation, that global data collection sites. We have a lot of, in the global, a lot of halophytes with market-oriented and non-conventional crops, any genetic material. And I would like to tell you the joint pilot research trial, digitalized monitoring, and one of the key users for policymakers, integrated pest management control. So we need to prevent any virus penetration, and we don't need to deal with this COVID once again. And of course, intellectual properties should be in place when saline agriculture is concerned, because here it's really very novel approach and it should be documented. And as I mentioned, women empowering, because women makes difference in the world. Finish.
Okay, thank you very much. I'm sorry for my time management. I have to work on it. So guys, you have another session that is going right now already for started 5 minutes ago, and it's a roundtable about sustainable land use. However, as I see, we still have a session going. Until they kick us out from this, you can ask questions, and we hope to answer. So does anybody have a question? No?
No question, but I want to thank you. Very interesting presentation and idea for seeds management. Thank you.
Thank you very much. If you have any question to any of the presenters in this session, first of all, I would like to thank everybody for making this presentation, and all audience for giving us questions. We really appreciate it. If you would like to contact with us, please let us know. We still are in the chat, or we will be getting questions. You can connect to us through Stephanos, and we will be happy to answer to you.
Thank you.
So, okay, so no questions. If there is no questions, I would like to close the session. And once again, thank you for joining us. I hope it was interesting to you, and we would be happy to answer your questions again.
Sorry, by the way, can you hear me?